Okay, so I'm just going to go over the notes that you did in class about arc length and area of a sector. So the first page is about circumference and arc length, and we know that the circumference we can find by doing pi times the diameter or 2 pi times the radius. And then these problems you just are practicing finding the circumference. And then here, this is the circumference divided in half because it says, what if you only wanted to go halfway around the circle? And then here, if you wanted to go 1/4 of the way around, you just do the circumference divided by 4. So the reason why we started out with circumference is because arc length is just a portion of the circumference. And so the way you find arc length is you just take the degrees, or the measure of angle, or of arc AB, divided by 360, so that gives you the portion of the circle. So if it's like 90 degrees over 360 degrees, that's going to be 1/4. And then you multiply it by the circumference, so you're taking the portion of the circle where the arc is, multiplied by the circumference, and that gives you the total arc length. Now, I talked about this in class when we were talking about the measure of the arc. The measure is the degrees, or how much of the circle it covers. The arc length depends on how big the circle is because you're multiplying it by the circumference. So like I mentioned, if you have a really big circle, the arc length would be longer. If you have a really small circle, the arc length would be shorter. Okay, and then on the back, on the next page, we have examples of arc length. So here, the arc measure is 70 degrees, so we do 70 divided by 360 times 2 pi r, which in this case is 8. So that would give us 28 pi ninths, or 9.7 approximately, and that would be in meters. And you're going to have a quiz on Canvas that it'll be multiple choice, and you'll need to keep it with pi, and all of the answers have pi. So whatever this is, that would be your answer. So on this one, the answer would be 28 pi ninths. And then down here, these ones were a little bit more tricky. The perimeter of this region, that's of the shaded region, so that's the grayed out one. So we have to find the arc length of both of these circles, which is going to be the same because the diameter is 9, which means the radius is 4.5. And then it's a semicircle. These are both, well, the arc is half of the circumference. So we do 180 degrees divided by 360. That would simplify to 1/2 times the circumference, which gives us 14.14, or 4.5 pi, like I have written over here. So we know that this side of this shaded region and this side are both 15. So we have 15 plus 15, and then the two circle portions are 4.5 pi and 4.5 pi. Altogether, that gives us 30 plus 9 pi, which would be about 58.3. And then this one, I thought this one was funny because it would be a ginormous cake. Like it says that this is 6.28 inches. So that's the arc length. We know the arc length is equal to the arc measure in degrees divided by 360 times the circumference. So if we have a cake that's divided into 8, this should be just 1/8. So 1/8 of 360 is 45 degrees. So we have 45 over 360 times the circumference. We divide by 2 pi on both sides. We multiply by 360 over 45, or we multiply by 8 here. So we get the radius is 78.9 inches. That's just the radius. And then the diameter is 157.8 inches. So that's like a huge cake. Anyway, so that is arc length. And then the other part of circles is finding the area of a circle. So the next page was finding the area of a circle. We know that the area of a circle is pi r squared. So these problems we're just practicing putting in either the radius or taking the diameter, dividing it by 2, like we did on this one, and squaring it to find that area. So the area of a sector, it's the same idea as the arc length, that it's just a portion of the area. So this part where you're putting the degrees over 360, that's telling you what part of the circle you have, and then you're multiplying it by the area. So if you have a third of the circle, you want to multiply 1/3 times the area, because that'll give you the area of 1/3 of the circle. So these are examples, and then I wanted to go over this one, because this one's a little confusing. So it says a spinner is divided into 12 equal sections, and the radius of the spinner is 4 inches. Every other section is shaded. Find the total area of the shaded region on the spinner. So I drew a picture here because pictures always help when you have a problem. If you draw a picture, it just helps. It helps you visualize it. So I did 12 sections. I colored in every other one, so I shaded every other section. And I found that the degree measure of the arcs would be 30 degrees. So each of these has a 30-degree angle here that's being shaded. So for one spinner, we would do 30 degrees over 360 degrees. Then we have pi r squared. It said that the radius was 4, so that's why I put in 4 here. So we get 4 pi over 3. But that's just for one spinner, so if we want all 6 spinners that are shaded, we have to multiply it by 6, which gives us 8 pi. That's approximately 25.1 inches. And that is how you find the area of a sector. So you already completed your homework on this, but I'm going to have you do a quiz just to make sure that you understand everything. And I want to see that you're proficient with finding the arc length and area of a sector, and that'll be our first lesson of remote learning.